Welcome back, you guys. Thank you again for joining us for another episode of curve sketching and transformations. Today we're looking at hyperbola graphs, and we did talk about them previously, and we say that their basic graph is going to be of the format f of x is equal to 1 over x, okay? And the expanded form, probably let me just use a y, is the a over x minus p plus q. Okay, we're going to talk about the transformations that allow us to move from here to there. So the first transformation here is going to be f of x minus p. This will allow us to get 1 over x minus p. Okay, then the second transformation of this one is going to be multiplying by a. So that's going to be a f of x minus p, which will allow us to then get a over x minus p then. And then the last transformation is going to be adding a q outside. Like this. Like that, okay? Again, like we stated in the previous graph for your quadratics, we say the first transformation is going to be a translation p units to the right. The next one is going to be a stretch along y-axis, where we multiply the y coordinates by a. And then the last one is going to be a translation q units upwards. Why? Because it's happening outside of the brackets. Okay, and that gives us that graph right there. And we stated that there are many ways we could be able to do this, but for me, the most efficient method has been to look at what happens to the points of asymptotes. Okay, so our basic graph is going to be, so here, let me just change the color. Okay, and the points of asymptotes. Like that. Now, notice how the points or the lines of asymptotes, to be exact, are actually the x and the y coordinates, the x and y axis themselves. Let me just make sure I label those properly. And if we're to put numbers on a, p, and q, giving an example, let's say we have y is equals to 2 x minus 3 plus 4. Okay, so what this does, we say that the first transformation is to shift your graph p units to the right, because it's a minus 3. Okay, so it means that our graph goes to the right 3 units. Okay, so the first thing that we're going to do is that we're going to have a graph that goes to the right. So what really goes to the right is going to be this line of asymptote, like that. So this comes like this. This is our graph. And notice how the y, the line of asymptote, is still there for that there. Okay, and then the next one is going to be stretching the graph along the y-axis by 2, and if you stretch it, the difference may not really be felt as much, but let's see how the graph is supposed to look like. So the graph becomes stretched like that. Okay, but the difference really is not going to be much. As you can see, it's still the same graph, and our line of asymptote is still there as well. And then the next one is going to be the third one, which is a translation q units upwards. So we are translating at 4 units upwards, and you will notice that the emergent graph will be something of the sort. Notice how this is supposed, because we'll move the graph to the right 3 units, this is supposed to be 3 because we're adding 3, okay? And the 2 though, the effect of the 2 is going to be understated because there's no points that we can point out as yet, right? But then the 4, we can be able to show that because we're moving the horizontal is centered. And this is your positive, and this is your other centered that we began with. And then we then draw our graph. Like that. So what they would like to see will be the fact that this is going to be at 4, this is going to be at the usual 3, and that's it for our curve sketching. Of course, you may indicate this point. You can be able to find those by making x 0, making y 0 as well, and it's possible you can be able to find those. There's no problem there. Okay. Thank you very much, ladies and gentlemen, for joining us, and we hope to see you again in the next video. Goodbye.